All right, we are in West Virginia. No, we are not in West Virginia. But what we are going to do is have joke of the day, because I know you've been waiting for joke of the day. It is the best part of the day, isn't it? All right, so let's get to it. So why were the teacher's eyes crossed? Why were the teacher's eyes crossed? Because she couldn't control her pupils. You know, pupils in your eyes, then pupils, students. Oh, I know joke of the day is the best part of the day. But you know the other great thing? Is being able to solve compound inequalities. So let's take a look at how to solve our compound inequalities. It sounds very complicated. It sounds very difficult because of the word compound. But what you're going to find out is solving compound inequalities is really not that complicated, because take a look at this compound inequality here. Notice that in order to solve this compound inequality, what I'm going to do, a compound inequality really is just two inequalities smushed together. That's all it is. And that's why compound inequalities really are not as complicated as they seem. So let's take a look at this compound inequality. We're going to solve it, and then we're going to go back and fill in these steps, because solving it will make total sense for the steps. So remember, in this compound inequality, if I'm going to solve it, the whole idea is that I want to be able to get this x right here by itself. Now, here's the catch. If this is all that was there, and this is all that you saw, then what would you do to get that x by itself? Sure, you would add 4 to both sides. So let's go ahead and do that. Let's add a 4 right here. Let's add a 4 right here. Now, a negative 6 plus 4 will give me a negative 2. And then right here, when I add 4, I get a 1/2 x. Now, do I flip that symbol? No, yeah, because remember, the only time that you flip that symbol is when you multiply or divide by a negative number. I didn't even multiply or divide, I only added. So I'm not going to flip this symbol. Now, here's the catch. What if this is all that you saw? Once again, I want to get that x by itself, but if this is all that was there, what would you do to get that x by itself? Well, yeah, you would add 4 to both sides. So let's go ahead and do that. We're going to add 4 here, we're going to add 4 here. Now, we've already said that when we add 4 right here, we get a 1/2 x. When we add 4 right here, negative 3 plus 4 is a 1. And once again, do I flip that symbol? Nah, I didn't even multiply or divide. And remember, I need to multiply or divide by a negative to flip that symbol. So I'm not going to flip the symbol. So hopefully what you're seeing here is that to be able to solve a compound inequality, you do what you would have done for a regular inequality. The only catch is you're going to do it to all 3 parts. So the steps then, quite frankly, are you're going to do all operations to all 3 parts. To all 3 parts. And that is the only difference between solving a regular inequality and a compound inequality. You just got to do it to all 3 parts. So now, when I want to get this x by itself, remember, once again, I'm trying to get that by itself, so what would it take? Yeah, I'm going to divide by that 1/2. And we've talked before that dividing by a half is the same thing as multiplying by its reciprocal. So that's what I'm going to do. I'm going to go for the jugular, and because it's cleaner, it's faster. When I multiply by a half right there, they cancel, and I'm left with an x. So now what I'm going to do is multiply by that, I'm sorry, not multiply by a half, but multiply by 2. Please excuse me. Multiply by 2 here, and when I multiply by 2 here, I get a negative 4. Well, I'm going to do that over here as well. Remember, do it to all 3 parts. When I multiply this side by 2, I get a 2. Now, do I flip the symbol because, hey, I multiplied? No. Very, very specific. When you multiply or divide by a negative, that's what flips the symbol. So yes, I did multiply to all 3 parts, but not by a negative. So my symbols are going to stay the way they are, and there is the solution to that compound inequality, because I have my x by itself. Now notice that in the directions here, it does say solve the inequality. We did that. Graph it. Okay, so now it's time to graph that solution set on a number line. Well, here is my number line, and notice that what happens is I've got a 1 and a 2 up here, and I've got a 1, 2, 3, and a 4 back here for my negative 4. Now, once again, when I graph this, I'm graphing these. These are the solutions. So if, and when I graph those solutions, I'm going to shade the solutions. So if this is all that I saw, then those solutions, how would they compare to that negative 4? Yes, they're bigger than the negative 4, because remember, the big end is with the big end goes with the bigger number, The small end of the inequality symbol goes with the small number. So the big end is with these. These are bigger than the -4. Small ends with the -4. So these are bigger than the -4. So here's that -4. Where's everything bigger than that? Yeah, everything to the right is going to be bigger. So I'm going to shade everything that works. Everything that's bigger is going to be everything up here. Now technically, that would go forever in this direction. However, there's a caveat to that. And the caveat says, well, what if this is all that we solve? Those very same solutions, how do they compare to the 2? Well, yeah, they're smaller than the 2 because the small end of the inequality symbols with them, the big end of the inequality symbols with the 2. The 2 is bigger than them. So here's the 2. Where's all the numbers that are smaller than that 2? Yeah, everything over here. So smaller than 2 is going to be everything here. So basically, I'm going to shade everything that is bigger than the -4 and smaller than a 2. That's everything wedged between. So now I simply have to decide, well, what about this -4? Is it a part of the solution set or not? Yes, it is a part of the solution set. And how do I know? Because there's an equal to part right here. So since that -4 has an equal to part, remember, we don't do closed and open circles anymore. We do parentheses and brackets. So the bracket is going to indicate that that -4 is a part of the solution set. Now we just have to decide this positive 2 right here, does it get a parentheses or a bracket? Well, it's not a part of the solution set because there's no equal to part here. So since it's not a part of the solution set, it gets a parentheses. And so here is the graph, the picture representation of that solution set. So we solved it, we graphed it. Now we need to write the interval notation. Remember, write the interval notation from the graph. Even if your directions say to do the interval notation then the graph, no, do not do it in that order. Do your graph first because the interval comes directly from that. Remember, it's as if I'm taking this number line and I'm stretching it on the floor and then I'm saying, okay, I'm going to walk on the solutions. I'm going to step on everything that got shaded. And I'm going to start as far left as possible. So on this number line, if I begin walking as far left as possible and I only step on the parts that got shaded, where will I start? Certainly at that -4. So I'll start at the -4. I'll go all the way up to where? Yeah, all the way up to that 2. Now, that -4, once again, is it a part of the solution set? Yes, it is, because there's an equal to part. So like we said before, it gets a bracket. That 2, is it a part of the solution set? No, it's not, because there's no equal to part there. So it gets a parentheses. And hopefully you can see that that definitely came straight from the graph. It's like we took the graph and went, it's right in front of your face. So that's why we do the graph first, and then the interval rolls right off of that graph. So we have solved it here, we've graphed it here, and we have our interval notation right there. We've done all 3 things that we need to do. So let's take a look at one more example because you know that I like for you to see lots of examples so that you're comfortable with it. We're going to do the very same thing in this compound inequality. We're going to solve it, we're going to graph it, and we're going to write the interval notation. So in order to solve it, remember, I do whatever it takes to get this x by itself. I just do it to all 3 parts. So in order to get this x by itself, what would I do? Yeah, first I'm going to subtract a 2 from all 3 parts. Now when I subtract a 2 here, I get a 7. When I subtract a 2 here, I get a 4x. And when I subtract a 2 here, I get a 16. Now, do I flip these inequality symbols? Nah. I didn't even multiply or divide, let alone multiply or divide by a negative. So now, what's it going to take to get the x by itself? Yeah, I'm going to divide by 4. And remember, I'm going to divide by 4 on all 3 parts. So when I divide by 4 here, ta-da, I get the x by itself. When I divide by 4 here, I get a 4. And when I divide by 4 here, I get 7/4. Don't worry about turning it into a mixed number, but always simplify that fraction. Always simplify if you can. Is there a number that'll go into both 7 and 4? Nah. So I'm going to leave it as 7/4. We're totally fine with improper fractions at this level. Now, flip those symbols because, hey, I divided. So do I flip the symbols? Nope. Good call. Good call. It's very specific. When you multiply or divide by a negative, that's what flips the symbol. So I'm not going to flip my symbol, and there's my solution. but we know that we need to graph that solution on the number line. So here's my number line. Here's my 0, 1, 2, 3, 4, and that 7/4, where does it sit? Well, that's tough to figure out, so I do need to turn it into a mixed number in order to figure out where it sits. 4 goes into 7 once with a remainder of 3, so that's the equivalent of 1 3/4, which sits right about here. Now, remember, in terms of being able to graph the solution set, here's what I'm shading right there. Now, how do they compare to that 7/4? Yes, they are bigger. Big end is with them. They are bigger than the 7/4. Well, the 7/4 was sitting right here. That's that 1 3/4. Where's everything bigger than that? Yeah, everything to the right. So I'm going to shade to the right. Technically, that would go on forever in this direction. However, we have that caveat right here. Those same solutions, how do they compare to the 4? Oh yeah, they're smaller because the small end of the inequality symbol is with them. Big end is with the 4. So here's my 4. Where's everything smaller? Yep, everything to the left. So I'm going to shade everything to the left. And like I said before, technically that would go on forever, but these solutions are wedged between these two numbers. These solutions are bigger than the 7/4 and at the very same time smaller than the 4. That's everything that sits right in here. Now, that 7/4, does it get a parentheses or a bracket? You're right. It gets a parentheses because there is no equal to part. So parentheses here. And how about that 4? Does it get a parentheses or bracket? Yep, bracket because of the equal to part. And so here is my picture representation of that solution. Now we just have to write the interval notation. And remember, it comes right from the graph. It just kind of is right in front of your face. So I'm going to start walking as far left as possible, only stepping on solutions. Where will I begin my walk? Yes, right here at the 7/4, but the problem is I can't really step on the 7/4 because it's not really a part of the solution set, hence the parentheses. Now I'm going to walk all the way up to, that's what the comma means, all the way up how far? To the 4. So all the way up to the 4, and that 4 is a part of the solution set because of the equal to part, it gets a bracket. And like I said before, basically it's like taking that graph and just going, it's right in front of your face. It just rolls off of the graph. So, hopefully that helps you with the compound inequalities. Like I said, yeah, it sounds difficult, sounds kind of scary because of the word compound, but a compound inequality is really just two inequalities smushed together. So you're going to do whatever it takes to get that variable by itself, and you're just going to do those operations to all three parts. I hope that helps. Have a great day.